So here in this video we'll discuss the conceptual questions of chapter 3 from the book James S. Walker. So here in this question we are given with these 4 cases, and we need to indicate which of these following quantities is a scalar or a vector. So first, the time it takes for you to run 100-yard dash. Now time, it's a scalar quantity. This should be scalar. Next, your displacement after running 100-yard dash. So displacement, it's a vector quantity. You can also see my second chapter videos where I've discussed all these quantities. Next is your average velocity while running. So average velocity is a vector quantity. This should be vector. Average speed, it's a scalar quantity. So this should be scalar. Now here in this question we are given that vector A plus vector B equals to 0. And then we need to solve these two parts. But before discussing these two parts, let's try to draw these vectors graphically. So vector A plus vector B equals to 0. Now suppose this is the direction for vector A, and the length of this arrow denotes its magnitude. Now vector A plus vector B should be 0. So vector B should be in the opposite direction such that its magnitude should be same as that of vector A, but direction is opposite. Then only the sum of these two vectors will be equals to 0. Now let's discuss the A part. Now in the A part they are saying that how does the magnitude of vector B compare with the magnitude of vector A. So the magnitude is equal, so equal magnitude. Now next in the B part they are asking how does the direction of B vector compare with the direction of A vector. So direction is just opposite, so opposite we can write. So here in this question we are given that there are two vectors A and B having non-zero magnitude, and then they are asking is it possible for A plus B vector to be 0? So this question is just opposite to the previous question that we discussed. So the answer would be yes. And let me show it here. Suppose this is vector A having some magnitude, say 5 meter, and this is vector B which is just opposite to this vector A, and magnitude is same 5 meter. So in this case the sum of vector A and vector B will be 0. So the answer would be yes. So here in this question we are given that A plus B vector is equals to C vector, and also A square plus B square is equals to C square. Then we need to tell how are A and B vector oriented relative to one another. Now here we see that the magnitude of A, B and C vector satisfy the Pythagorean theorem, and also the sum of A plus B vector is equals to C vector. So it follows that A vector, B vector and C vector forms a right triangle with C as hypotenuse. Let me show this on the figure. Suppose this is the direction of A vector and this is the direction of B vector. So A vector plus B vector is represented by this arrow. This would be the C vector. In this case all this and this condition is satisfied. Thus we can say the angle between vector A and vector B is 90 degree. Therefore they are perpendicular to each other. So this would be the correct answer for this question. Perpendicular to one another. So here in this question we are given that vector A plus vector B is equals to C vector, and also the magnitude of A vector minus the magnitude of B vector is equals to the magnitude of C vector. Then we need to tell how are A and B vector oriented relative to one another. Now from here we can say that the magnitude of A vector is greater than the magnitude of B vector. Suppose that the magnitude of A vector is 5 units and the magnitude of B vector is 2 units. So the magnitude of C vector would be 5 minus 2, which is 3. Now let us try to draw these vectors. So suppose this is the direction of vector A. Now vector B should be collinear and opposite to the vector B, so that these two conditions are satisfied. So let this be the vector B. Now what would be the vector C? This would be the vector C. This should be the vector C. Therefore we can say that the vector A and vector B are collinear and in opposite direction. So here in this question we are given that the component of A vector satisfies this relation. Now we need to find the possible direction of A vector. Now from this equation we can say that the component of A vector is not equals to 0, and the equation is Ax is equals to negative of Ay. We can also rewrite this equation as negative of Ax is equals to Ay. I've just taken this negative sign here. So there can be two cases possible. First case, when x component is positive, y component is negative. Second case, when x component is negative, y component is positive. So let us draw the first case when x component is positive. So this would be the case. Now one more question arises, its angle, the direction. Now here you see that the magnitude of the components are equal. So this angle should be 45 degree, so that Ax and Ay, if you see the magnitude from here, the magnitude of Ax and Ay is equal. So this angle should be 45 degree for this condition. So this would be Ax and this would be Ay. And here Ax is equals to negative of Ay. And next case can be this one. So this would be the x component of A vector, Ax, and this would be the y component, Ay. And here the y component is positive and this x component is negative because it's along the negative x direction. Now this angle should be 45 degree. Now we generally measure the angle from the positive x direction. So this angle theta, it should be 135 degree. So finally we can write there are two cases possible. The first case is the angle should be 45 degree clockwise from x direction or x axis. The next one is 135 degree and this angle is anti-clockwise from x axis. So here in this question we are given that rain is falling vertically downward and you are running for a shelter. Now the question is asking that in what direction you should hold your umbrella so that you are protected from the rain. There are three options given: vertically, tilted forward, or tilted backward. Now this question is purely based on relative motion. The velocity of the rain related to ground is in the downward direction, and the velocity of the person relative to the ground is in the horizontal direction and in the right side. Now if we are able to determine the velocity of rain relative to person, the direction, if you are able to determine, then we can give this answer easily. Now from the concepts that we studied in the relative motion, we can write that the velocity of rain relative to ground is equals to the velocity of rain relative to person plus the velocity of person relative to ground. And from here we can write VRP is equals to VRG minus VPG. So simply we have to subtract these two vectors to find this direction. Now VRG is in downward direction. Let me represent it also. So this is VRG. Now if VPG is in the right side, then minus of VPG would be just opposite to this with the same magnitude. So this would be minus VPG. Now what would be the sum of these two vectors? Basically what we are doing is we can rewrite this equation as VRG plus minus of VPG, and this is what is equals to VRP. Now we have to add these two vectors to find this direction. So addition of these two vectors is represented by this arrow. So this is VRP. If you have any confusion regarding this, you can see my videos where I discussed the vector addition graphically. So this would be the direction of rain relative to person. So it is coming like this. Relative to you, the rain is coming like this. So you should hold your umbrella in the forward direction like this so that you are protected from the rain. So the correct answer would be you should hold your umbrella tilted forward.